Assalamualaikum and good evening to our lecturer. So today we will conduct radial heat conduction experiment. As you can see, heater power cord need to plug in, and thermocouple need to plug in. One, D2, D4, D5, D6, D3, and the last one is D7.
After connecting the thermocouple and the switches, we need to turn the pipe.
Okay.
After turn the pipe, we have to turn the off. Make sure the water flowing to the drain. After that, we need to switch on the main power and we need to turn on the heater switch. And we need to set to the lowest temperature.
Then we set the power to 30 watt and we wait for the temperature to stay. Now our temperature has stable, so we can record the data and write on the table sheet. For T1 is 36.5 Celsius, T2 is 33.3 Celsius. Now we repeat the step to change the watt to 50 watt and 90 watt, and after that we take their data.
After we done doing the experiment, we need to set the power into 0. Switch off the water supply. Switch off the heater and power supply.
Assalamualaikum and good evening to our lecturer and our friend. So today our team will explain how we conduct our lab 2 radial conduction. So my name is Muhammad Syarikman bin Jasdiman. Our team is Muhammad Khairul Adha bin Roslan, Muhammad Syafiq bin Muhammad Sharif, Tan Weziang, and the last one is Sasitaran anak lelaki Baratarajo. Okay, next I will explain our result outcome. As you can see, table 1 shows different power for radial heat conduction experiment. For the first one, we set our power in watt 30, 50 and 90, and we take the temperature data from T1 until T7. So as you can see, our first watt is 30, and from T1 until T7 it shows the temperature is decreasing. 50 watt also decreasing, and 90 watt also decreasing. The radius from T1 is 0, T2 0.01, T3 0.02, T4 0.03, T5 0.04, T6 0.05, and the last one radius is 0.06.
After getting the result, we construct a graph. From the result of data, we construct temperature of a radial distance for all the 3 heater power used. From the graph, we see the distance of all the temperature for each watt. that is 30 watt, 50 watt, and 90 watt decreases when the thermocouple is getting far from the heat source. Also, the temperature of each thermocouple increase when we set the heater power to the high part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Karada Hafid Roslan and I'm going to explain the discussion number 1. For discussion number 1 is to choose one of your set of results. Use the equation in the theory section and the actual value of T1 at its radial position to calculate T2 at its radial position. Use the calculated value to find T2 and T3 and continue in this way to find the theoretical value of the other thermocouple. Add the theoretical curve to your chart and see how well it predicts the result. Okay, for L equal to 5 mm or 0.005 meter, for T1 equal to 345.4 Kelvin, and W equals to 90 watts. Typical thermal conductivity for material brass is 123 W over Wisp amps times K. For T2, we use the formula T2 equals to T1 minus with W times with ln R2 divided by R1 over with 2 pi times with L and times with K. Then we insert the data and T2 equals to 338.955 Kelvin. We use the same formula to find T3 until T7, which is T3 equals to 319.1511 Kelvin, T4 equals to 312.81 Kelvin, T5 equals to 307.613 Kelvin, T6 equal to 303.366 Kelvin, and lastly T7 equals to 299.776 Kelvin. Then we add the theoretical result of T into the chart and compare with the experimental result of T at the set power of 90 watt. That's all for me. Thank you.
Good evening to everyone. Right now, I'm going to present about the discussion. Question number 2. Question number 2. Discuss the cause of error between theoretical and experimental data. So, data reading, we get data reading error due to non-uniform heat flow. Error does happen when doing the theoretical calculation. Besides that, the surrounding temperature also affect the temperature result in the experiment. Apart from that, the consumable material is not in good condition. Then there is a reading error because the user is not skilled in using laboratory equipment when conducting experiment. And finally, there is unknown aspect in the experiment such as electrical composition and precision can also indicate mistakes.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Muhammad Sharif. My metric number is B09201039. Today I would like to explain about conclusion. First, from this experiment, we learned that heat flows around a solid disk with uniform dimensions and materials. Second, we identified the heat transfer methods such as conduction, convection, and radiation. Third, we learn the steps that need to follow when calculate the experimental thermal conductivity of the material in a solid disk uniform dimension. Fourth, thermal conductivity is inversely proportional with temperature difference and length. And lastly is the temperature can be increased cause more power is applied. That's all. Thank you.